Hi, this is a new video part of the research project Analog Spiking Neuron Model for Unsupervised STDP-based learning in neuromorphic circuits. For my master thesis, I am going to talk about the project today. I wanted to talk and to focus on unsupervised learning topic. The question, what is unsupervised learning, might be obvious, quite obvious for some of you, but I had the question multiple times, and I know it can be mysterious for some of us, including me at first sight. So here's the video for popularizing unsupervised learning. In fact, if we talked about supervised learning, one may not even need any mathematical demonstration as a proof of learning capabilities, because it quite makes sense that if we keep correcting an algorithm, which by the way look like more this thing than this thing. So if we keep correcting it by saying yes, you're right, it's a cat, or no, you're wrong, it's a dog, and stuff like that, it quite makes sense that the algorithm will tend to learn and to do good at the end. I mean, it's not disturbing. Yes, this is the same for reinforcement learning. So if we keep correcting and directing an algorithm by saying, yes, you're right, or no, you're wrong, this is the same. I mean, it's not disturbing that it will tend to learn. But when it comes to unsupervised learning, it's much less intuitive how it could work. How it could learn. So if we do not provide any feedbacks, if we do not say anything to the algorithm, how could it learn anything? And in fact, unsupervised learning is used only to certain type of application. It is often employed to find patterns into data. So the machine goal is to build a representation of the inputs. And it can be used for decision-making or prediction of future inputs. Also, efficient communication of the inputs with other machine, and so on. For instance, it's famous in clustering and also in autoencoder. So Garmani here in 2003, I mentioned his work because he did a really great job. Really great introduction and review about unsupervised learning, and he goes into math explanation, which are quite accessible for everyone. So you might need, of course, some statistical knowledge, but yes, this is still accessible and very interesting. So if you want to dig deeper into unsupervised, because I won't provide any math demonstration, math explanation, so you might read his article. So let's give a very simple and concrete example. You have here different symbols, and let's assume that you don't know what it is, and you don't know because I'm the one who made those ugly drafts. But still, you might see and easily say that there's two different type of symbols here, and you might tend to separate them into different classes. But you can't name that because you don't know what it is. But still, you can create two different groups. And that's also what does the computer, in fact. Of course, it doesn't see the image as you do, but it will represent them in an n-dimension space, depending on the input. Here, I choose to represent in a two-dimension space for simplifying the explanations and visualization. But it could work with any type of input, and so yeah. Let's say that those inputs are represented here in this two-dimension space, and what the computer does is the machine will estimate a model that represents the probability distribution of the past inputs. And so thanks to a well-defined mathematical algorithm with a loss function and all the stuff, it will tend to do good model. And we can see that the fine-tuning here is very important, because we could have scenario where the model is too selective and will tend to not represent well the inputs and the different class, or it could also be not enough selective and create only huge model which are not very representative of the inputs. So based on the past inputs, the machine is able now to classify new inputs. So because let's assume that the new input here is this blue stuff, and let's assume that the representation of this blue stuff is here, right inside the red model. So because it belongs to the red model, the machine will be able to classify it and to say that it's being part of the red class. And now let's imagine another input which is represented here, and because it's not inside any models, it will not be classified, or it will be classified with the algorithm will create another model, a new model, but it can be classified as being red class or orange class. And that's basically explains unsupervised learning without any math. As I told you, if you want math demonstration, you might have a look to Garamani 2003 right here. You can find his paper on Google Scholar for free. And now I wanted to do a quick parallel with human learning because I think it's very interesting. And it is believed, and it quite makes sense, that all human beings use unsupervised learning, and also, of course, other type of learning. But unsupervised learning would be overriding at first, because at the very beginning of our existence, we don't know anything about anything. So, for instance, in order to learn language, you will just listen to your environments, and feedbacks are not really possible because you don't even understand them. And real world is also quite complicated to imagine here for language. So you just hear sounds, and sounds are made of huge amounts of frequencies. But fortunately, our brain is like an amazing sponge, gathering a huge amount of information from our environment. And let's assume here that Tom, which is an ignorant baby, doesn't know anything about anything, but he has seen many things, and he has seen a large amount of cats and dogs. Let's imagine that. And of course, he don't know that there are cats and dogs, but still he can say that there are differences and similarities between stuff he has seen and he has heard and he has felt and so on, because the stimulation provided by what he has seen are different. Thus, he might create a model of representation as the computer, as the machine does. And he might separate cats from dogs because the simulation is different, as I told. And from this point, he don't need anything else to increase his dataset. So even if he don't know what it is, let's assume that he's seen another animal, another image, and because the stimulation provided by this image is quite similar to the class he has built, so this class, he will classify this image, so this animal, as being from this class. So that's as simple as that. And now let's imagine that one day someone says, "Oh, that's a cat," and so now he will be able to put a label on this class and to say, okay, all the inputs, this dataset is represented cats, and it's even better than that, because he has seen a lot of cats. He has seen a lot of cats, and he has also heard a lot of times the sounds cats. So now he's able to create a class of cats, of image from cats, and also a class from sounds cats, and he will be able to bound those two classes to create like a bigger class from the sounds cat, from also maybe the smell of cats and the image of cats, and so that's basically how human can learn with unsupervised learning. So from this point, Tom, which was very ignorant, he will be likely to say by seeing a cat that it's a cat, and so to pronounce it, to bound the sound cat with the image cat, and to still increase his data set. And it's even better because let's assume that Tom now is older and he has learned a lot of stuff, and he has created another data set about tiger, and he has seen many tigers and a lot of movie on tigers and read about tigers, and so he has created a new data set about tiger, and so he will be able to correct himself his data sets, because nothing is fixed in the human brain, and there's plasticity notion, and so you can modify your knowledge and what you've seen and what you've create and all your beliefs. And so he can create his data set in order to know what to better define his model of cats and to create new data sets. And yes, that was a quick parallel with human learning. That's all for this video. I hope you've learned some stuff and you enjoy it. And yeah, it will be useful for next video about STDP learning, because STDP is an unsupervised local learning role. So if we have to remember something, if you want to remember something about this video, you should remember that unsupervised learning is defined by machine building a representation of the inputs, and it's very good for finding patterns into data and clustering. And in fact, it's sometimes combined with supervised learning in order to increase the data sets by an unsupervised learning, which will create and kind of create and select some database, and the supervised learning will learn with more data thanks to some supervised machine learning. And so yeah, next video will be about STDP learning. I hope you enjoyed this video, and I say bye bye.